Now the question is, how many functions are there, or what are those functions to be performed on the list? Or we can say, hey, we are able to add the items. We are able to add the items. But what about if I want to delete something? What about if I want to change any value? Is it possible? What about if I want to check, let's say I created this list, but I forgot whether T is present or not in that list, right? So is there any way to find out whether tea is present or salt is present? That's what we are going to see now. Okay. So let's continue with this example. Um, when you write shopping list and dot, it will tell you all the functions available to your list. The very first function is add, where you can add new items, correct? Then there is another add which says that at particular index, if you want to add the item. So for example, I want to add something just before T, okay, or just before toy. Let's assume just before toy, I want to add something. So there is already first item, second item, third item, fourth item, fifth item. Fifth item is toy. But I want to add something between salt and toy. Between salt and toy. I want to update my list. So what you can do is you can say shopping list dot add at particular location. So I want to add it at index 4. So you have to provide which index. This starts with 0. So this is 0, this is 1, this is 2, this is 3, this is 4. So here at the fourth index, I want to add something. What do you want to add? You want to add, let's say, biscuit, or let's keep it simple. We want to buy bag. Okay, bag we want to add. But then is it added or not? So as of now, I will not go it through for loop. Let's print the shopping list to check whether this bag is added and where it is added. Let's print it and let's run this. So there is one function add, which is overloaded function. You can add a single value also, or you can say at particular position, I want to add bag. So this example, if you see the last one, fruit, watch, tea, salt, and then bag is added at the fourth index. And then toy shifted. I think toy is shifted. In between salt and toy, bag has come. It's like this. Fine. That is one function. Let's do more thing. Let's do more thing. Once you write shopping list, it will show you all the options available. And not all the functions are useful for us as of now. So this one is adding some other collection values to another list. We don't want to do this. Add all will be like adding in a particular index, not required. Clear. This one is good. What clear will do, it will clear out all the values. I'll do it at the end. Okay, so that because we want to see all other functions, right? Contains, this one is good. If I want to check, hey, whether T is present or not, whether T is present in my list or not, you can use it. Okay. So this will give you Boolean value, true or false. It will tell you whether it's true or false. So if I'll say my shopping list contains T, I'm checking. Contains is a function which will tell you whether a particular value is present or not, right? So it's giving me true. Let's change it. Let's make it like It's like egg. Okay. I'm putting egg. But egg was not there in the whole list. Egg was not there. See here in this list, fruit, watch, tea, salt, toy is there, bag is there, chocolate mug is there, but egg is not there. So it should print me false. Let's run this. See here, it's saying me false. So it's very easy. You just say shopping list contains egg. So it's checking whether it contains egg or not. It's like this. Okay. What other function we have? Let's check shopping list. Shopping list dot. So contain is fine. Contains all we are not going to do. Equals. So you can check one list with another list. You can check one list to another list whether those are matching or not, right? Get, we are already have seen get function. We have seen dot get function. So get will get you a particular value present in a particular index. Okay. So get is fine. What else? Then is empty. Is empty will tell you whether your uh, list is empty. There is no value. I'll do it at end of it. Last index of. So that is a good thing. So list allows duplicate value. Let me write it. That is a property of list, right? What is the property? First thing, list is, let me write it properly first, sequence of added items. Added items. First thing, correct? Second, list allows duplicate values. It's possible. What we are saying with the list is you added, let's say, already added, let's assume toy. But that doesn't mean you cannot again add the toy. You can still add it. So if I want to add again toy, it's possible. I'll say toy again. Okay. And let's print it just to show you that toy will come 2 times. Toy will come 2 times. Okay. As of I'm commenting out this line. The toy is added and everything will be added at the end. It's not like that randomly somewhere it is added. If you see the last one printed, fruit, watch, tea, salt, bag, toy, chocolate, mug, toy. Again, there is a toy. Okay. Because you have added it at 48th line, you said that I want to add toy again. So list allows you duplicate values. Okay. I was talking about a function last index of. So I want to check when I added the toy, right? At where, at what line number it is present, or in a simple word, it's like at what index it is. So for example, there are 4 values. There are, let's assume there are just 4 values. If I'll say the last index of t, so it will tell you 1 because index of salt is 0, index of tea is 1, index of fruit is 2, index of watch is 3. It's like in some building, the floor starts with 0th floor. First floor, second floor, third floor, right? In the ground floor also, we don't say it's a ground floor. It's in the lift, you say 0. Okay, 0th floor. In the same way, this list concept works. 0th value is salt. It's like this. And now, if I add t again, it's possible. You can add t again. Okay, so you can say t, but the index of this will be 4. Okay. So now if I want to find out When was the last time? It can be a big list of 500 values. I am giving you a very simple example. 500, 5,000 values can be there. If I were to find out when was the last time I added, at what position, T. So I'll say, find out the last index of T. In this example, we are finding what is my last index of toy. Okay, let's print it directly. So index of will give you one integer value, one numerical value, which will tell you when when was the last toy was added, at what position. So it's saying at 8th position there is toy. At 8th index the toy is present. Okay, it's like this. Fine. What are other functions we have? Let's try. So shopping list dot. When you write dot, it will automatically give you all the options available with this. Okay, so we are seeing it. Okay, is empty. I said that I'll tell you later on. Last index is remove. Good one. So you can remove something based on two things. You can remove, let's say I want to remove something which is present at first position. Okay, at index 1, it's not the first value. Again, understand it. When you say remove 1, okay, it will not delete fruit. Let's understand. If I'll say shopping list dot remove 1, it will not remove fruit. It will remove watch, because fruit is 0. 0th index. Watch is 1 index. T is 2 index. Index 2. So here remove 1 will actually remove watch. Okay. Let's see what will happen once you remove it. So I'm going back here and let's print it. So what should get deleted? I'm running it here. See here, fruit, and then directly T is there. Watch is not there, which was there earlier. That's it. You can remove it. You can remove it by actually putting what you want to remove also. So for example, I want to delete mug. That's possible. You say remove mug. Okay. And let's print it again after the deletion. That's why we say list is dynamic in nature. You can add and remove anytime. If you see here, we had mug, right? See here, we had mug earlier, but now mug is deleted. And automatically shifting is done. So whenever mug is deleted, toy will come automatically next to chocolate. Toy is deleted, sorry, mug is deleted. So after the chocolate, there was mug. Now after the chocolate, toy is there. Okay. In that only sequence. So remove function is, you can remove it by index, you can remove by value also. Okay. What is next? So there are other functions. We are talking about all possible, generally what we use, right? Remove all will remove all. Okay, I'm not doing it as of now. You can set. Set means add and set are two different things. Set is you are replacing it. So let's understand. Instead of fruit, I want to say banana. Okay. I don't want to say fruit. I want to exactly say banana. So what I can say? I can say at 0th index, make it banana. P-A-N-A-N-A. Okay. And let's print that list again so that things will be clear whether it's working fine or not. I'll copy this and I'll print it again. And if I'll run this, so at any position you can add, you can set the value. So there is a difference. Add will shift the values. Set will actually replace it. So instead of fruit, now there is banana. It's like that. In place of fruit, now there is banana. Rest of the things are same. It will not change. You're saying that at 0th index, make it banana. So it will delete fruit and put it banana. It's like this. Whereas add is different. What add does, it will add whatever you will provide at the end. It can be duplicate also. So there is a difference, add and set. Now the last one which I wanted to show you is simple one. I want to say show shopping list dot. So there is a function is empty. So is empty will check whether your shopping list is one empty list or it has values. Okay. So is empty is a function which will show you whether your list is having some value or not. It's saying false, means it's not empty. It's showing me false. That means it is not empty. Let's delete all the values. What you can do, you will say shopping list dot remove all. Is there any function? Remove all. Yeah, remove all is there. Let me put it without saying anything. Is it possible? No, just a minute. Sorry, just remove. But every time it requires something. So I'll say remove, and in bracket, if I do something, it is asking me that you cannot do it in this way. Okay. Is there any function which will actually delete everything? So that is clear. Okay. Clear means clear out all the things. Now, if I'll check that is it empty? So this time, if I'll run this, it is saying me, yes, it's empty. Why? Because you cleared out everything. And if you will, print out all the values, will it retain the values? No. You cleared it out. You flushed it. So see here, it is not having any value now. It is not having any value. Moreover, if I'll run that program again, this one, where we found out the count, this one, right? So let's say I want to capture what is the size of my list now? How many items are there, right? So if you do it again, let's see what it will print. So it's saying me 0. See here, it's saying me that there is 0 item. It is doing all these things, fruit, watch, tea, added. Then we did whatever things. We added some value. We print that whether something is present or not. We print how many items are present. We removed something. All those things we did, like line by line. But at the end, at line number 62, we are saying clear it. So it will clear the whole list. Delete means the items will be deleted. Shopping list is still alive. Means the space is alive. You created a shopping list, right? So it's alive. It's alive. You can add values here one by one. Okay. But it is empty now. You delete, you clear it out. It's like this. You can add fresh shopping list now. So once it is clear, that doesn't mean you can add, you cannot add it now. You can still add it. Let's do it. But it will be a fresh list now. So if I add it here again, let's assume fruit. So that will be a new kind of list. It's not that old list. Okay. So if I'll print it here, it will show me just one value, which is fruit. See here, just one value. All other values gone. You added it explicitly in 69th line, again a new value. But at 62 line, you said clear it out. So it will be empty then. Then that's why it is printing, because of line number 64, it is printing me this. Because of line number 67, it is printing me that there is a 0 item. Size of the list is 0. Okay. That's it about how to work with the list and all. And it allows duplicate value, and it works through index. Okay. It works with index. There is a particular index. Okay. It's like this. The good part is you can add, update, delete. Update means changing it, right? All these things are possible. In fact, search also. You can use contains function. Very easy. That's why list is very handy. People use it, use the list, quite frequently if you want to store, the values which are in sequence, right? So you work it with list, and it's dynamic. Dynamic means you can add, update, delete, and search. So that's why we say it is dynamic. Okay, dynamic in nature. So if somebody will ask you in interview, hey, what is list? So theoretically, you should say that list is one interface. Okay. I'm not going to technical part of it as of now, because I'll cover the interface part later on, and then we will come back to what is list, what is set, different type of, what we say collection. I'll come back. But as of now, understand it. List is simply a dynamic kind of list of elements or the item. List is sequence of added item. List allows duplicate values. It works with index. So it preserves the order. Technically, we say it preserves the order in which you added the value. And it's dynamic. You can add, update, delete, and search. If you will tell like this to interviewer, they will understand in a very simple word that what you are going to talk about list. Okay. That's it for today.